Right now, tonight, there are an estimated 100 billion planets in our galaxy alone that could support life just like yours. Not one of them has ever said hello back. Not a signal. Not a probe. Not so much as a flicker in over 60 years of listening. 200 billion stars, trillions of planets across the visible universe, and in all of that, silence. Total, unbroken silence. So ask yourself this: if the universe is this big and this old, where is everyone? In 1950, a physicist named Enrico Fermi sat down for lunch with his colleagues at Los Alamos. They were joking about aliens, about flying saucers, about how common life must be out there. Then Fermi asked one simple question that stopped the conversation cold. Where is everybody? It sounds almost too simple to matter, but the math behind it is what makes it terrifying. The universe is 13.8 billion years old. Our sun is only 4.6 billion years old, a relative newcomer. That means there were more than 9 billion years before Earth even existed for other civilizations to rise, evolve, and spread across the galaxy. 9 billion years is enough time for a single spacefaring species to colonize an entire galaxy, even moving slower than the speed of light. Send out probes. Let them build copies of themselves at the next star. Repeat that process for a few million years, and you've covered every star in the Milky Way. A few million years sounds like a lot. On a 9 billion year timescale, it's nothing. It's a rounding error. So if even one civilization out of the billions of planets out there had done this, we should see it. We should see the evidence everywhere. Structures, signals, waste heat from megascale engineering, something. We see nothing. That gap between how likely life should be and how empty the universe looks is called the Fermi paradox. Scientists don't agree on why it exists. They've spent 70 years building answers. Some of them are reassuring. Some of them are not. Let's start with the one everyone wants to be true. We're early, not late to the party. Early. The universe is still young in terms of when it can support complex life. Red dwarf stars, the most common stars in the galaxy, will keep burning for trillions of years. Our sun will die in about 5 billion. If most stars haven't even reached their prime yet, maybe intelligent life is rare simply because the universe hasn't had time to produce much of it. We might be one of the first, not because we're special, but because we're early. That's the comforting answer. Here's the one that isn't. It's called the Great Filter. The idea is that somewhere on the path from lifeless rock to galaxy-spanning civilization, there's a barrier, a filter almost nothing gets through. And here's the part that should genuinely worry you. We don't know if we've already passed it or if it's still ahead of us. If the filter is behind us, if it's something like the jump from simple to complex cells, a step that took Earth nearly 2 billion years to accomplish, then we got lucky. We're rare. We made it through the hard part already. But if the filter is ahead of us, that's a different story entirely. That would mean every civilization that reaches our level of technology eventually hits something that wipes it out. Nuclear war, runaway artificial intelligence, climate collapse, something we haven't even discovered yet. And it happens to all of them. Every single time, without exception. That's why, to some researchers, the silence isn't just a mystery. It's a warning shot. Okay, take a breath, because it gets weirder from here. There's another theory. Colder. Quieter. It's called the dark forest hypothesis. Picture the universe as a dark forest at night. Every civilization out there is a hunter. And in this forest, the rule is simple. If you make noise, something bigger than you might hear it. So the only survivable move is to stay silent. Don't broadcast your location. Don't answer if something else does. Because you have no way of knowing if what responds is friendly or just very, very hungry. Under this theory, the universe isn't empty. It's terrified. and every civilization that's advanced enough to survive has already learned to shut up. Then there's the zoo hypothesis, the idea that they're already here, watching, and simply choosing not to interfere, like scientists observing a nature reserve without ever stepping past the fence. Unsettling? Maybe. But at least in this version, we're not alone. We're just not ready to meet them yet. And then there's the simplest explanation of all. No hiding aliens, no filters, no forest. Maybe intelligent life really is just staggeringly, impossibly rare. Maybe the exact sequence of accidents that produced you, a stable star, a moon large enough to steady our axis, a magnetic field, plate tectonics, the right chemistry at the right moment for billions of years straight, has only ever happened once. Maybe we checked every box on a list so long and so specific that the odds of it happening twice in one galaxy are close to zero. Nobody knows which of these is true. And that unknown is exactly what makes this the most unsettling question in all of science. Here's what nobody tells you about the Fermi paradox. It was never really a question about aliens. It's a question about us. Because every theory that tries to explain the silence loops back to the same unanswered thing. What happens to a civilization once it becomes powerful enough to reach the stars? Does it grow up? Does it destroy itself? Does it learn to go quiet on purpose? We are, right now, standing in the exact window where that question gets answered. We have the technology to send signals into the dark. We don't yet have the technology to leave this solar system in any meaningful way. We are standing exactly where every filtered civilization, in every theory, would have been standing too. So when you look up at the night sky, you're not just looking at a silence that's billions of years old. You're looking at a test that every planet with life on it has had to take. And so far as we can tell, every single one of them has failed it, gone quiet, or is still taking it right now, same as us. 100 billion planets that could hold life just like yours. And somewhere among them, right now, someone else might be looking up too, wondering the exact same thing about you.